Hey everyone, we're gonna talk about today about functions in Solidity. So I'm gonna be doing a different type of prompting into ChatGPT, a different type of asking questions. So I'm gonna have multiple windows here. So let's try to keep an eye on what's happening. So first of all, we're going to ask ChatGPT about functions and Solidity, but we're going to start a conversation. We're going to say something like, I want to have a conversation with you, but pretend to be a Solidity professor that teaches in, I don't know, 2050, just as a reference. And teaching 5-year-olds, right? So we're gonna try to Eli 5 everything you reply to me. Okay, we're gonna try to have a conversation with the robot, but from a perspective of a professor. I just wanted to put it in 2050 because why not? Let's try and see. I don't even know what it would sound like, but let's see. So it says, of course, I'll be happy to pretend to be a Solidity professor, that 2050 is not even an issue for it, and talk to you like I'm teaching 5 years old. Let's get started. Just remember, Solidity is a programming language used to write smart contracts on the Ethereum blockchain, but I'll try to explain it in a way that even a 5-year-old can understand. So I think that's a success. First prompt was a success. We're going to ask him a couple of questions. So first of all, let's feed him a little information, a little bit of information. We know from our previous classes, we already know a little bit, right? So let's talk about that. So I want to learn about functions, right? That's our topic today. I already know a few things about Solidity. I know there are 4 types of variables: uint, int, bool, and string, and nothing else. And I do ignore everything else. All right, so let's give it a little bit of format. I said ignore because it's easier to say that than I don't know anything else. It's pretty much the same, but it's just straightforward. Want to learn about functions? Please tell me about them. So that's the prompt for us today. I want to learn about functions. Please tell me about them. And now a little bit more about me. This is what I know, and that's all I know, right? That's what we learned from our previous classes. What is uint? What is int? What is bool? What is string? What are the differences? They're all variables, but let's see what it tells us. Great job. Remember, it's talking to us back to as if we were 5 years old in 2050. So hopefully we'll get that perspective. You already know some important things about Solidity. Now let's talk about functions. Think of a function like a recipe for making something. Just like a recipe tells you what ingredients you need and what steps to follow to make a cake, a function in Solidity tells the computer what to do. For example, let's say you want to make a digital cookie jar. The cookie jar should have a function that lets you put cookies in it, and other function that lets you take cookies out of it. These 2 functions would be like recipes for putting cookies in and taking cookies out of the jar. Now, recipes, I'm not sure it's getting the right word for it, because a recipe might feel like something you use to make the cookies, right? So it's kind of weird that it's using this word, but what it means is if a recipe would say, open the jar, put your hand in the jar, take a cookie, put it out the cookie, eat the cookie, that would be a recipe. But um, I'll leave it there. Hopefully, in the future, we'll get something better than recipes because functions are like recipes in the way that it has an instruction, it has a step-by-step guide. But putting in and putting out cookies, I don't think that's a recipe at all. That is a function. So it would be like a recipe, but it's not a recipe for putting cookies in and taking cookies out. Okay. So does that make sense? Yes. Functions are an important part of Solidity and can help you make all kinds of smart contracts. Well, functions are the basic part, the most the thing that makes everything inside of a contract. So you could have just a contract with variables, that's okay, but you still need functions to read it. And if you don't want to write it, that's fine, but just to read it, you'll need some. So let's move on. Let's say, does that make sense? Yeah, I don't want to get into the recipes thing because I want to move on. I want to continue. That's why I gave you the hint. So yeah, that is that makes sense. Yes, that makes sense. Continue. Let's see what it tells us. Next step. So when you write a function in Solidity, you need to give it a name, and you will just like you would name a recipe. Well, yeah, okay. So let's think of a recipe as a function then. We'll call it that. Every time we see a recipe, will mean function, right? So let's try to continue with that word. You also need to tell the function what it should do, using the steps you would use to make the recipe. For example, here's a simple Solidity function that adds two numbers together. In this example, the function is named add numbers, and it takes two inputs, A and B, which are both uint, unsigned integers. We already know that, right? The function returns a result, which is the sum of A and B. This is pretty simple. If we were making a Solidity calculator, we will definitely need a add numbers function that takes in parameters and takes out some numbers too. This would be values. You can use this function in your smart contract to add two numbers together and get the result. Does that make sense? Let me know if you have any questions. Well, I might not have questions. I might have other type of questions, but let's see if we can actually guess some of the questions some people might have. So explain this part. I want to know, what does that mean? I call those parameters, but what are those? So this is the input parameter, right? So input parameter are numbers or variables or strings or booleans, whatever, that we send into the function. And in the other side, we're going to have something here, right? Return. That return is going to be something else. So let's see what it says. The part is called functions. Okay, first of all, this seems a little bit too long. So let's try to give me a brief answer, please. Let's try to just shorten it down. We'll still read it, but I want to compare. This part is called the function's input parameters. That we already talked about that. Just like when you make a recipe, you need ingredients to start with. In the same way, a function in Solidity needs inputs to start with. And the inputs are the parameters of the function. So parameters are just variables that go inside of a function. We'll have other values or variables that go outside of the functions, but those are not input parameters, okay? In this example, it gives us add numbers, takes two inputs, which is kind of hinting that unsigned integers can only be positive whole numbers. And when you call the function, you need to give it two numbers to use it as inputs. The function will then add those numbers together and return the result. Does that help? Yes. Now, the brief part, the uint part of the function definition are the inputs or parameters for the function. These are inside. Let's That's not exactly what we want, but it's also explaining because that's what we ask. And when the function is called, values for A and B must be provided in order for the function to work. Yeah, so you cannot call the function without those values. So, all right, we like this. But it gave us a really interesting example, a digital cookie jar. So let's ask for a code. Nice. Let's work on some code for digital cookie jar. Let's see what it gives us. And what I'm going to do from here is I'm going to take this code, I'm going to move into a new chat, and then I'm going to ask it to explain it to me, what it does and how it's moving. And every single line of here will be included with some comments automatically. So I just asked for the contract for the digital cookie jar, which is pretty simple. And it's called cookie jar. So the contract's name is cookie jar. We're going to read it right away, but we have a variable, which is public variable, right? We saw that last class. It's called cookies, and it's a number. And then we have two functions, a function that adds cookies and a function that takes cookie out, right? So this puts a cookie in, and this puts a cookie out. Now, there's an if here. We're not going to worry about that too much. We're going to move on and see what it tells us. In this contract, we have a public variable cookies, which is this one, to keep track of the numbers of cookies in the jar. We also have two functions that let you add or remove cookies from the jar. And the take cookies function takes the input and checks if there are enough cookies in the jar to remove. Now, this is important because if you want to take out 100 cookies and there's only 10, you shouldn't be able to take any of them. That's what our contract says. Okay? But it could be a different way of working if that's what we wanted. If we wanted to change the contract and have a different behavior, we could make it. So just right now, if you ask for 11 cookies and there's 10 cookies, you're not going to be able to take any cookie out, not even 9 or 8 or 5 or 2. If you have to ask for the right amount of cookies to be taken out. All right. You've done a great work. So let's copy this code. And I'm going to start over. I'm going to say, hey, good morning. Please take a look at this code and electrify it for me. So explain like I'm 5 for me. I'm giving it back to you. This is the code you just created. Now explain it back to me. And then after it, we're going to ask it to add some comments. So what it's going to electrify for me, we're going to put that text, we're going to take the text and put it in as a comment. So let's see what it tells us. Almost done, almost done. Let's wait a little bit until it's done. I don't want to just interrupt it or get interrupted. All right, perfect. Hey there, this code is a simple Solidity contract for an imaginary cookie jar. Well, I like the word imaginary, but I said digital, which could hint digital is imaginary, but okay. The contract has two functions, add cookies and take cookies, which allow you to add or take cookies from the jar. Now, remember, this is supposed to be a different chat, a different robot, right? It's just getting all this information from the input that I gave it, allegedly, right? We don't really know what's going on. Now, the public cookies line defines the public state variable. We already saw that, this line. And the name of the variable, which is public, it's cookies, right? So this is a state variable. This is a unsigned integer, and this variable represents the number of cookies in the jar. The add cookies function takes an input num cookies and adds it to the cookie state variable. The public keyword means that this function can be called by an external contract or user. Take cookies function takes an input and subtract it from the cookies, but only if there are enough cookies in the jar. This function uses an if statement to check whether cookies is greater than or equal than num cookies before making the subtraction. The contract is written in Solidity, which is a high-level language for writing smart contracts on the Ethereum platform. Okay, all good here, all good so far. Now, let's add the comments here into the code, right? So, thanks. Pretend to be a Solidity teacher and rewrite this code to include comments as you provided. Keep your answer, your comments brief and elify them, please. Right, so we're asking for the code, we're asking for some comments, and we're asking to keep the comments brief and focus for kids, for people that are 5-year-old kids, pretty much. But anyway, let's see. Let's hopefully we'll get a really cool function, a really cool contract that we're gonna take into Remix and give it a spin and see how it works. Now, all right, this goes now easier to understand and follow because the added comments provide context and clarification for each line of code. Perfect. I trust you. Let's see. Let's see. So this line define a public state variable named cookies that stores the number of cookies in the jar. I don't think this is eli5 enough, but it's fine enough. Function to add to the jar. One sec. Oh, Lau is coming. Welcome, Lau. Hope you're doing great. Hey, Lau, welcome.
Hey, how are you?
Doing great, doing great. Creating a cookie jar. So we are recording this class, so you'll be able to replay it, and we'll go back into the start as soon as we come in. Just a brief explanation of what we've been doing. We asked ChatGPT to teach us about functions. That's what we're learning today, functions with the variables that we already learned. So we're learning about functions, and it came back that we're going to be creating a cookie jar, which has a cookie jar contract, which has two functions, and we just asked them to add some comments because it just explained to us what it's doing. Oh, also, we took the code that it write for us, we created a new chat, and then we gave the code back to it, and we asked him to explain it for us. So I think that was interesting because from a new perspective, it's giving a explanation of something that we gave him, a code. That could be something we see on the internet. We can ask him to read it for us and explain it to us. Or it could be a code that we write, or it could be just code that he gave us in the first place. So that's where we're at. That's this code with these comments. And we're just reading through it. This right here means that this function is to add cookies to the jar. And then here it says, increase the number of cookies in the jar by the amount specified in the num cookies input. So this is the rule that we have right here, right? And that rule says cookies plus equals. This plus equals means add it and set it. So whatever this cookies is, increase it in this amount, num cookies, which is a parameter right here. We already talked about a parameter versus a value. And then we have a function to take cookies out of the jar. So we also have the same parameter. How many cookies do you want to take out of the jar? And then first we have to check if there are enough cookies in the jar to take the specified amount. And if there are enough cookies, then subtract the specified amount from the jar. Now this is pretty similar. We have an equal and a minus. This means reduce or decrease. The right word is decrease. Does anybody has a question so far right now?
Well, no, I get it. Thank you.
Perfect. All right. So we're gonna copy this. We're gonna see. We're gonna ask him today. Um, awesome. I want to test this code using Remix. Remix is the tool that we already used before. We're gonna use that to copy and paste this code, and then create the code and try it out ourselves. Can you explain me how to do it? So, oh, I forgot to ask him to keep it brief. But let's see. He's gonna ask us. He's gonna probably give us a step-by-step guide. Pretty straightforward. I think it's almost over. Well, no, I don't. I don't think so. Let's start clicking here until it's over. Just so it's loading, and you can start seeing the tool while the chat is over. So this tool is created. Make sure you are on ethereum.org. This is the Ethereum Foundation website, which is the official website of Ethereum. So it's ethereum.org. This might change at any time in the future, so could look different. So they created this tool for us to learn and to make it easy for us to connect to the blockchain and test stuff. Okay, so it's ready. So let's see. Remix is an online Solidity IDE that allows you to write, deploy, and test smart contracts. Here are the steps to test cookie jar contract using Remix. Open Remix in your web browser, done. Paste the code for the cookie jar contract into the Remix editor. Click on the compile button on the top right corner to compile the contract. This will check for syntax errors and compile the contract into machine readable code if there are no errors. Wait a sec. Eli 5 this for me and keep it brief. All right. While it's doing that, let me just keep this quite quick read through this. Once the contract has compiled, you can click on the Run button. In the environment section, select JavaScript VM. Okay, that's going to be important. In the contract section, select cookie jar contract, and you can now interact. Well, I have to click deploy, so there's a step missing here, but that's fine. You can now interact with the contract by calling its functions. For example, you can add cookies. You can also check. Let's see the Eli 5 version. Remix is a website where you can write and test smart contracts like a game where you make the rules for a computer. You can write the rules for a cookie jar and see if the computer can follow them. To test the cookie jar rules, you copy and paste them into Remix, then press a button to see if they work. You can also play with the rules by adding or taking cookies from the jar and seeing what happens. Interesting. This is a way for it to explain like M5. Doesn't say a lot of stuff, but it's fine. So it says go here, paste the code, click compile, and then, no, interesting. It says click run. I've never tried that. We might try it as well. So one thing it didn't tell us is you have to copy it where, right? So paste the code into Remix editor, where here. So we're going to click on new file. I'm going to say this one is called cookie jar, right? So it's going to be cookie jar. So new file, cookie jar, and just press enter. I'm going to move it inside of contracts just to keep things clean and neat. I don't like it being outside. So it's inside of contracts. We have a lot of other files here, but we have cookie jar and it's empty. So we're going to copy the code. We're going to come here, copy the code, paste it, and it's going to tell us, hey, wait a minute. You just pasted something. Are you sure this is safe? Yes, I am sure it's safe. Now, what was the next step? This next step is, let's see here, press a button. Copy, paste them into Remix, then press a button. Okay. Here it says compile and then run. So we're gonna go here to this Solidity compiler. Here on this tab over here to the left, I clicked on this one. So the third one, we got the files, we got search, and then we got compiler. We're gonna click compile, and we're supposed to be getting compile and run. That's what they said, but that's not what it says here. I think it asks us to come remix London. All right. In the environment, once it's click the run and then environment. Okay, let's click run just to see what happens. Run script. Okay, it says something went wrong. I don't really need that, to be honest. We're gonna check remix. We have remix VM. This is a virtual machine. It's not a blockchain that's connected to anything else. It's a private imaginary blockchain that we have created here in this website. And that's how we're gonna connect, because we're not gonna be using MetaMask right now. If we had, we'll just click on injected provider, but right now we're not. So we have a bunch of accounts already created for us. Limit and the contract. Here's the important part. Cookie jar. We're going to select it. Right now it's the only one, but in the future you might have different files here. And then we're going to click deploy. When we click deploy, it's going to be real fast because we already have a contract. And this is the way that we're going to interact with our contract. We have two functions, and we got another function that was created automatically because we said cookies are a public variable. There's a function that's created just for it, and it reads the number inside. So it's like a transparent cookie jar. We could have made it private, and this would have gone away. So you can only take an ad. You don't know how many cookies there are. And right now, anybody could take cookies in and out of the contract, so that makes it unsafe. Next class, we'll talk about how to make it safe. Right now, let's just add cookies. So let's add 5 cookies. Click transact. As I said, it's really fast because it's a local remix, a local blockchain. So we don't need to go to MetaMask, confirm the transaction, wait for it to happen. We just clicked on it, and then we click back, and we have 5 cookies now, right? So we click on cookies, and we got the 5 updated right here. Now let's add more cookies. Let's add a bunch of cookies, right? Sorry. How many cookies do we have? Oh, wait. No, where to go? Here it goes. We have this amount of cookies. Now let's take cookies out. And let's try to get more cookies than what we have. When we try to transact with this, take cookies, it shouldn't work. It is not giving me an error, right? It's just working. But the cookies do not update. That's because we added this if right here. If we wanted to break, if we wanted it to break, which would be better, right? Not just spending gas trying to do something that it's not possible. This should be better if it would just break. We will need something different than an if. Similar, but different. We'll see that also next class. So let's try to remove a significant amount of cookies now, but still lower than the amount of cookies that we have. And now we're back to regular numbers, and we only have 5 cookies here. So we added a function to add this, create a number. We added this in, so we could just use regular numbers. We clicked transact, and now we have, sorry for that, we have 7 cookies inside of the jar. We can take cookies outside of the jar, say 3 cookies out, and this 7 should change for, let's see. Now there could be something wrong. For example, if we try to empty the box, empty the jar, now we have 0 cookies, right? What happens if we try to take 1 out? It just goes back but it never goes under zero, right? So we can try to take cookies. We don't know how many cookies there are, but there are actually no cookies being removed. Now, we said anybody could um, edit this contract, which is unsafe because if anybody finds your cookie jar, they could just take cookies out, take cookies in. You wouldn't notice. You wouldn't know who tried to put it here. So that's a couple of things that we could do to improve this cookie jar. What if we want to make it a safe cookie jar that only you can access? And I think that would be safe enough. But also, what if we keep a log and track a registry of who is taking what amount of cookies and why? So let's keep that in mind for next class. Let's make a small, well, I'm just going to ask him for it while we're here. Um, got it. Please improve this code to make it secure in a way that only I can edit the call the functions to my cookie jar. What else? What else could we add? Oh, also, yeah. And also create a registry. I'm going to call it ledger. Ledger of how many times people have. Well, you know what? It just gave me an idea. Have moved cookies in my jar. This just gave me another idea because I want anybody to be able to deposit cookies. So this could be like a way for us to just have people pay cookies, right? Like we just want people to put cookies inside of this box. And then we want to be able to take the cookies out. That's fine. But this is like a box that we're going to pass around to people to put cookies in. So putting cookies in the jar is fine. Taking cookies out the jar is not fine. So let's just put it like that. Putting cookies in the jar is okay for anyone to do, but only me, only I can take cookies out. Actually, just so I don't have to edit everything else. Let's give it a prompt to make sure we can add an address straight variable to store the owner of a contract and use the require statement to enforce restrictions on who can take the cookies from the jar. Here's the updated code. We're not going to be testing this right now. I'm just going to be copying it and putting into Remix. But this would be part of what I expect people that are looking at this video, either a replay or are looking at this live right now, that we're going to be getting into. This is a bit, I don't want to say extreme, but it's something a little bit more complex than what we have done before because it has a mapping and it has a struct, so we haven't seen those. But it's a good enough contract that we want to get next week or next month or next anything. This is a good goal for us to understand what's going on because we just went from nothing to, let me do cookie jar version 2, cookie jar safe. I can't just copy paste it. Okay. All right, let's just create a new one. I can right click here, cookie jar v2.sol, and cookie jar, I'm going to just call it here, version 2 updated. And I'm going to also write the prompt that I gave so that I can remember later on. Okay. This is not the exact prompt, but it's the last prompt that I gave. So it's okay. It's good enough, at least for me. I'm going to save this here. So every one of you would have these two versions. Now, because each one of you are going to get a different type of result. So it could be in Spanish, it could be in English, it could be English, but a different type of English. Anything could happen. We're going to have different contracts and we can share and see how the robot made these functions. These are pretty simple functions. There really isn't anything else to do, but let's try to do it here. Let's see. It's keeping all the comments in. I like that. So we still have a mapping, which is fine. Constructor, all right. That was new. We didn't have a constructor before. Take cookies, add cookies, and we have now, I'm not sure, way much more code than what we had before. This is pretty simple, pretty good to start, but this would look something like it has more potential to have a value of why do you want to keep all this information. Now, this doesn't have events, right? So we could have just created an event. That would be something that we could have just asked here. No, and well, we have all this. So I'm just gonna save it for later. We're gonna move on. We're gonna see if, oh no, all the way here. Now we're gonna move with the questions from our students. Before we move into questions, sorry, let me go back and see what we did today. We started with this. We said, I want to have a conversation with you, but pretend to be a Solidity professor that teaches in 2050 and is teaching 5-year-olds, right? So we try to ELI5 everything for me. Now, that's fine. Just remember this is blockchain and like I'm not going to get into that, but let's go on. And now I told them a little prompt. I want what I want to learn about. So today I said functions, and I already gave him a small input about what I did know. I know about variables. I know about uint. I know about int. I know about bool, and I know about string. And I ignore everything else. So that's all I know. Don't worry about that. But then worry about everything else to tell me about functions. So as an ELI5 teacher, Solidity expert, it told me a function is like a recipe to make something, right? So we saw a function that has some steps. Every function started with just one step. That's a simple, and the least you need for a function is one step. And a recipe tells you what ingredients you need and what steps to follow to make a cake. So or a recipe or contract or functions tell us what to do to make what? To make a cookie jar, right? So that's what we got the idea of a digital cookie jar, which would have two functions, one to put cookies in and one to take cookies out. And then I just said continue, move on. All right, perfect. So when you write a function, you need to give it a name, just like you would a recipe. And you also need to tell the function what it should do using the steps you would use to make a recipe. And then explain add numbers. This is another function that we saw in the beginning of the class, which is defined as a function. The name is add numbers. It takes in two parameters. We're going to call them parameters, and it returns one value. In this case, we said it here, returns a number. And in this case, this is the only step that we have in this recipe, in this function, is one step. Pretty different than what we had. Then we asked him to go deeper, didn't really give us something interesting to work with. And then we asked him for the digital cookie jar code, created this code, and then we moved into a different chat, and then we created all this thread. We said, hey, GM, take a look at this code and explain like in 5. And it just explained what the code did, everything that it did. And then we asked them to add the comments. We gave it the code, add the comments, and explain everything that this code is doing. So this is pretty interesting way for us to write code. Now we ask him to tell us how to test using Remix. We went to this page, we paste everything. It was missing a couple of steps, so If you cannot achieve that, it's fine, but try to get there. And then we ask them, this is very important, you also have to do this part. Ask him to improve the code, make it secure in a way. You can use whatever words you want to use, but this is the objective, the same objective that you want to do. And just make it add some extra rules and make it add some extra stuff for you. And copy and paste it and save it for us, and we'll review it next class. Let me now go back into the chat, stop recording.